Thanks for everyone. This semester's seminar series of Yaşar University's Industrial Engineering Department kicks off with Gözde Ulutugay. Professor Dr. Gözde Ulutugay joins us from Izmir, but she works at Istanbul Gedik University's Industrial Engineering Department. She's a graduate of Ege University Statistics Department with honors in 2001 and has her master's and PhD degrees from Ege University and 9 Eylül University. And she has she's received an honorary certificate from the Graduate School of Natural and Applied Sciences in 9 Eylül University due to her researches published during her PhD studies. She apparently also received a bunch of awards that I'm not going to go much into detail. Very nice. She worked as a research assistant at the Ege University, a TÜBİTAK scholar at 9 Eylül University, an assistant and associate professor at Izmir University. And she also visited computer science department at the University of Texas at El Paso as a visiting researcher. Her main research interests include, but are not limited to, fuzzy clustering methods, data mining, multivariate statistics, artificial intelligence, and big data analytics. She's teaching undergraduate and graduate courses in these areas. And not only that, we have just found out that she actually does project work with Bahçeşehir High School. I don't know if they call it a special name, Fen Lisesi at yes, so technical college, high school of science, whatever is the I'm sorry, the proper name is, and that's also very interesting work. Today she will be giving her seminar under the title Shades of Gray, Fuzzy Thinking. It's about fuzzy logic and soft computing technologies. We're looking forward to her talk. Hocam, the floor is yours.
Hello, Hocam. Thank you for your nice presentation. I'm very glad to be here, and thank you for your kind invitation to Özgür Hocam and whole department of industrial engineering. Let me share so I can share my screen. Hello, Hocam.
Yetki vermek gerekiyor olabilir. Mahmut Ali.
Panelist yapmıştım. O yetmedi mi bilmiyorum. Bir daha bakayım şöyle. Nedir? Make co-host. Şimdi bir daha deneyelim lütfen hocam.
Okay, can you see my screen? Can you see my screen?
Yes, we can.
Yes.
Okay, the yin-yang symbol, as you know, stands for a world of opposites and world we often associate with Eastern mysticism. And it is the emblem of fuzziness. That's why I decided to use in the beginning of my slides. And the theory of fuzzy logic provides a mathematical tool and mathematical strength to capture the uncertainties associated with human cognitive processes such as thinking and reasoning. And we can say fuzzy logic is a way of model logical reasoning where the truth of a statement is not final, and there is a soft transition from absolutely false to absolutely true because of that. I want to use emblem to show you the relation. And generally, we say that the fuzzy principle states that everything is a matter of degree. So I wanted to start with an apple. Suppose you hold an apple in your hand. Is it an apple? Yes, it's an apple. And the object in your hand belongs to the clumps of space-time we call the set of apples, all apples anywhere ever. Now let's take a bite from it and chew and then swallow it. And is the new object in your hand still an apple? Yes or no? There is an answer here. Take another bite and slow down to avoid the apple change its form from thing to non-thing and nothing. can say. But where does it cross the line from being an apple to being a non-apple? When you hold half an apple in your hand, the apple is as much as not.
Hocam, Gözde hocam, I'm sorry. Are you now currently viewing the first slide still? Because I think
No.
we are seeing the first slide. You're not.
No,
Okay. Maybe restart that.
Okay.
Are you in presentation mode?
Yes, I'm in the
Okay,
presentation mode.
because
Can you see my apples?
No, we see that it is the second slide, but we view the first slide only for some reason.
Hocam şova alırsanız belki görürüz. Şeydeki PowerPoint'i şova alırsanız şu aşağıda olması lazım.
Yes.
Yok sağ altta.
Yok zaten onu yaptım hocam az önce de.
Öyle mi? Şovda görünmüyor bizde.
O
Şimdi
hangi
elmayı
hangi ekranı paylaştığınızla alakalı.
Bütün ekranınızı
hocam.
paylaşın. Evet, değil mi? Bütün ekranı paylaşınca olacaktır. Sadece evet. Şimdi mesela değişti. Şu an ne olduğunu bilmiyorum ama.
Hala şovda değil.
Evet.
Slide şovda değil hala.
Hocam tüm ekranları paylaşın dedikten sonra büyük ihtimalle çözülecektir program.
Ya da desktop.
Ya da desktop.
Elma geldi mi şimdi hocalarım?
Yok, şimdi sizin hala şeyiniz dönüyor görünüyor ve birinci slayttayız.
Evet hala şovda değil yani şov modunda değil.
Şunu da bir deneyeceğim. Evet, zannediyorum şimdi oldu. İlerletirseniz hocam bir deneyelim. Evet, şimdi elmanızın birini görüyoruz.
I took a bite from this apple and swallow and I just asked you that in which manner this apple changed from being an apple to a non-thing, from being a thing to non-thing, and where does it cross the line from apple to non-apple? And when you hold an apple for all or none descriptions, we can say the half apple is a fuzzy apple, the gray between the black and white, we can say. And fuzziness is grayness and things flow smoothly to mountains in general, we can say. And let's come to the historical perspective. Before I show the outline of my speech, I just want to give the historical perspective. Of course, it goes 2000 years ago, start with Aristotle when he came up with binary logic, which is now the principal foundations of mathematics. But I will just not go further. We can say that fuzziness has a normal name, a formal name. In science, multivalence, we can say it is the opposite of fuzziness in bivalence or two-valuedness. And there are two ways to answer each question: false or true, 0 or 1, black and white, we can say. And fuzziness is multivariance. It means multivariance, and it means 3 or more options, perhaps an infinite spectrum of points instead of just 2 extreme options. It means analog instead of binary, infinite shades of gray between black and white. And logicians in the 1920s and 1930s, as I said, I don't go much earlier. In these years, they first worked out multivariate logic to deal with, say, Heisenberg's uncertainty principle in quantum mechanics. And this math principle says that if you measure something precisely, you cannot measure other things as precisely. And the principle suggests that we really deal with 3-valued logic statements that are true, false, or indeterminate in general. In short order, and Lukasevich, logician Lukasevich, chopped the middle interdeterminate ground into multiple pieces and came up with many-valued or multi-valued logic. Then he made the next step and let indeterminacy define a continuum, a spectrum between falsehood and truth, between 0 and 1. And on this fuzzy logic, statements like grass is green or Izmir girls are beautiful can have truth value or a degree or fraction between 0 and 1. And there is any percentage between 0% true and 100% true, we can say. And after that, the term fuzzy entered the scientific library and scientific literature about 30 years later, Lukasevich, we can say, until the logicians Bertrand Russell used the term vagueness to describe multivalence. And in 1937, Max Black published a paper on vague sets, or what we now call fuzzy sets. He differs from Russell in that he proposes that traditional logic can be used by representing definition of vagueness, confused vagueness with generality, we can say. And the world of science and philosophy of course ignored Black's paper, unfortunately, as you might now be discussing the history of vague logic, not fuzzy logic, we can say. And in 1965, Lutfi Askerzade published a paper called Fuzzy Sets. Here is his set, his article. The paper applied, in fact, Lukasevich multivariate logic to sets or groups of objects, and Zade put the label on, fuzzy on these vague or multivariate sets whose elements belong to different degrees, like the set of people satisfied with their jobs. In fact, fuzzy logic didn't come of age at universities. The Western scientists objected fuzzy logic in the beginning, and it came of age in the commercial market of Japan. Fuji, Canon, Hitachi, Honda, Mitsubishi, and Sharp, Toyota used it in commercial market, and then the universities and researchers started to deal with fuzzy logic and make some great contributions to the area, we can say. And here is the biography of Lutfi Askerzade. Unfortunately, he passed away 4 years ago, and until his death, he worked actively in the university and made speeches and communicate with other researchers. He was a nice man. And I had a chance to meet him in several conferences. This was when I was young. I was a research assistant here, and it was in Germany. And man next to Zade is Victor Page. Maybe you know about him. He is the chief editor of the famous journal Information Science. And the other one, Nasibov is my PhD supervisor. And I also had a chance to visit him and give a seminar in his office with my daughter. She was 8 years old at that time. I think she's very lucky. She is now a medical faculty student, and I hope she will use physiology with a proud that she met with Zade at that time. So, physiologic is a tool, a big tool in the artificial intelligence technologies. So it is the mathematics of artificial intelligence, in fact. So we have fuzzy logic systems, fuzzy inference systems. I will mention these two sections in my seminar. And we have adaptive neural fuzzy inference system, which we call ANFIS, machine learning, artificial neural networks, deep learning, soft computing, computing with words. And there are some nature-inspired algorithms, genetic algorithms, anticolon algorithms, and others. So artificial intelligence finds its mathematics basically by fuzzy logic, we can say. And, artificial intelligence system is a system that can make decisions under uncertainty, as we all know. And there is a Turing test, or we call Turing machine in artificial intelligence, which was proposed by Alan Turing in 1960s. And according to this test, there is a wall, and in each side of the wall, in one side there is a person, and in the other side there is a computer and another person. And a lone person asks some question to the next side, but he doesn't know, doesn't know whether the machine is answering or the person is answering. So if he cannot decide that, so and the machine is answering that questions, so it's a good artificial intelligence, we can say, and this is the famous Turing test, we can say, in fact. And when we come to evolution of machines with artificial intelligence, of course, we can say that there is a change from measurements to perception with emotion. And also there is a change from numerical computation to conceptual computation. So in fact, we use, we take our actions and we act by thinking further, not by using mathematical computation in our mind, and we don't solve some differential equations to act in some case, we can say. For example, for a machine or for a person, of course, these are extreme examples, but as a CRISP, CRISP means classical, like the opposite of fuzzy, we use the term CRISP here. Turn up the TV volume by 17%. What is this? What does that means to you? So no one can understand this. But if I say as a fuzzy command, turn up the TV volume or a little or a lot, so I can say yes. That's an easy thing for me to do. But I don't compute in my mind mathematical terms. So, in fact, fuzzy logic is technology that tries to model human thinking and human style of reasoning by using simple commands. So I have questions. I ask these questions in my lectures to the students. What is the age of an old person? What is the weight of a fat person? What is the speed for a fast car? Or what is the height of a tall building? I think you have some definitions in your minds for these concepts. And you can ever give an average for an old person, or a range. You can define a range. So there are some measurement units for all of these 4 questions to answer my question. But what about spicy, dangerous, sleepy, funny? How can we define these adjectives? What is the meaning of spicy to a Turkish person, or from a Chinese person, or from a Hindu person? What can we, Indian person? What can we? Be the answers for this? Or what is the meaning of dangerous according to a baby, or according to a mountain climber, for example? It changes from time to time and from situation to situation, we can say. And I have an example here, and I will turn back to that example later. According to the local herbalist who has several years of experience, a young person should drink 20 grams of herbal tea a day, and an old person 50 grams of herbal tea a day to stay healthy or stay fit. Of course, these are just examples, not real values. In this case, how many grams of herbal tea should a 45-year-old person drink a day? Another question, how many grams of herbal tea should a person who is not very old drink a day? So, to solve such kind of problems, we have some subjects to deal with. Fuzzy logic will help, fuzzy sets, fuzzy numbers will help to answer these questions. And of course, when we use fuzzy logic, we need to know some fuzzy operators, fuzzy sets operators, similar but different from classical set operations. And we need to define linguistic variables, some operations on linguistic variables, fuzzy roles, and fuzzy inference system. And we have some types of uncertainty. We have some types of uncertainty. So we are curious about the distinction between randomness and fuzzy. Objective uncertainty, which we call stochastic uncertainty. For example, a patient's probability of recovery is 80%. In that way, he will recover, probability 80%. He will die with 20%, you can say. So stochastic uncertainties are the interest of probability theory. But we have some subjective or perceptual uncertainty by using fuzzy logic. In that case, instead of giving the probability of recovery, we say that a patient's recovery is 80%. So he got some cures from the doctor. He is not absolutely fine, but he feels better. So with some degree, he recovered. He needs some time to get better, to reach 100% degree. So we can say subjective uncertainties are of interest of possibility theory. Or I can say there is a 20% chance to rain. So this is the probability, and there's an objectiveness here according to some measurements and from the past experience. We can say, but if I say there is a light rain or hard rain, in that case, probability, the 20% probability occurred. But then we look from the fuzzy logic window, we can see that there is a light rain. So it rains, but light rain from probability concept. So I will show you a figure. Maybe I'm not. I don't know. This figure will be an ellipse or a circle, and there's a 50% chance for every occasion. let's say, and this is the probability and objectiveness in that case. And or I can say in the next slide, I will show you a figure, and it will be an inexact ellipse. And here there is fuzziness and subjectiveness, we can say in that case. So this is the circle or ellipse, but in real world, we don't have this perfect figures, or we don't have perfect whites and perfect blacks. There are just the colors, I mean the grays in the extreme values, we can say. And before starting the mathematics of fuzzy logic, I need to remind, of course, I know you well know, but to find the difference, I want to show the classical set. So as you remember from high school information lectures from you learned, we can define sets by lists, for example, a list of any numbers, I can say, the letters of my name or the universities in Izmir, I can say, or I can sometimes define a rule of membership. I can say, I can deal with prime numbers less than 100, or names in my student, names of students in my class, I can say. Or sometimes we can define a function of membership. For example, I can define a set A as the temperature at which water will boil. In that case, if the water boils, it gets the value 1. If not, it gets the value 0. There are only two possible answers. But, for example, we have two different waters, different things, I can say. One of them is 10 degrees centigrade, and other one is 90 degrees centigrade. So both of them are not boiling, but the first one, I mean the 10 degrees centigrade one, is far from boiling to as 90 degrees centigrade. The next one, the other one, the 90 degrees centigrade water is just far from boiling point to 10 degrees. So we can say that we need to talk with the fuzzy sets here. How much does x belong to the function? Now, instead of the elements 0 and 1, only the elements 0 and 1 in the set, as the set membership, I mean, now we have a continuous interval between 0 and 1. And we have a transition in the building logic, in the binary logic, we have yes or no, black and white, and true or false only, and there is a strict transition between these two truth values. But in the multivariate logic, we need to define as a degree of membership. And because of that, I said shapes of grace. And this is another example of Venn diagram. This left-hand side figure is an example of a crisp set. So we have a universe of discourse, and inside this universe, we have a set A and two elements. One of them is exactly inside this set, and I mean, it is an element of set A, and B, on the left-hand side figure I'm talking about, it is not an element. Actually, we know that. But for fourth set, I mean the right-hand side figure, now we have a fuzzy set A. The element A is inside the circle or the set, and it is absolutely element. B again is not an element, but what about C? It is in the boundary. So that element may be an element or may not be an element, but it's better to take this element as a member of the fuzzy set A by taking into account the membership degrees. Or suppose we define the height according to some database we got this, or according to our calculations. There are some 10 people, I think, here. So person who is longer than 180 centimeters is absolutely tall, according to the CRISP. The classical logic. They have the membership degree 1, but unfortunately, David is an element of not tall or short or average, what else set. But in the fuzzy case, since we take into account the membership degrees, and since we have the soft transitions between being tall and not being tall or short or average height, I don't know. We have the degrees. Oh, okay, Chris and Mark are long people, are tall people, I'm sorry. And John is also tall, but with a degree of 98%. And it means he is not a tall person with 2%. And let's count Bob, for example. He is not tall in means of classical sets, but he is 15% tall in means of fuzzy sets. So we have membership functions and membership degrees. So we can define some membership functions. These are all subjective functions. The concept of tall could be different for me and different for all of the participants here. But suppose there is a threshold here, as for the CRISP sets. If a person is, the height of a person is less than 180 centimeters, he is short. And if more than or equal to 180 centimeters, he is tall. So there is a strict S here, we can see. But as I mentioned in the table, in the previous table, we can think the transition as a soft transition. So there is a sigmoid-like function here. So there is a soft transition from being short to being tall. So I can say, for example, a person who is 180 centimeters is only at 80% element of a tall set, you can say, and or conversely, 20% element of a short set, short people set, we can say. Then, in general, CRISP set, as we know, has precise binaries. So we have a characteristic function which gets values 0 or 1 if an element X is an element of set A. It belongs to set A. It has a membership degree 1. Otherwise, it gets the value 0. But fuzzy set has a fuzzy boundary, has fuzzy boundaries. So its characteristic function mu X, or it is called the degree of membership or membership value in different literature, we can say. So there is a continuous interval, closed interval here, 0 and 1. And if it's totally belongs to A, it has a membership degree 1. It is not in A, it has a membership degree 0. So it is the spatial case of fuzzy sets, which we call CRISP set. But in some cases, if it is partly in A, so with varying membership degrees, it can change the value. And this is the fuzzy representation. Again, these representations can change from people to people, or for communities. It can also change the definition of short or tall can be different for Turkish people and for Chinese people, or for the people who deals with NBA, for example, NBA players, of course, it will be different. And for the first figure, we define the short people, which are less than 170 centimeters. And if a person is between 170 and 180, it is an average height. And if he is longer than 180 centimeters, he is absolutely tall. But in fuzzy sets, we can define various kinds of various types of. These are the trapezoid and the triangular examples of membership functions, but we can define in other ways. For example, for a person who is 185, for example, is here, he is tall with only 40 degrees. But for a person who is 182, for example, I will go to upper of the figure. So look at the intersection points of each figure. So for a person who is 182 centimeters long, he is an element of, for example, here, tall set, tall people, element of tall people with 10%, but he is an element of average people with 40%. So fuzzy sets allow us to have to be an element of different sets with varying membership degrees, we can say. And in the set operations, classical set operations, as you know, we have the union, intersection, exclusive and subtraction operations, and many other properties hold for classical set operations. But when we come to fuzzy set operations, suppose we have two fuzzy sets, A and B. Fuzzy set A is the red one, like the whole figure on the whole triangle in the left-hand side is red in the initial one, and right-hand side triangle is the blue one. It is the set B. So when I take the union of these two events, two sets, so I need to take the membership degree of each element, which has a larger membership degree to each. So I need to compare it. So for the red board lines here, we have the union operation applied to our fuzzy set. So, for example, if an element is, if a point is an element of fuzzy set A with 0.6 degree and element of set B from 0.8 degree. So when I take the union of these two sets, so this element is the element of union of these two sets from the larger degree, which is 0.8. I need to take that into account. So we use our operator here. For the intersection, we have again two fuzzy sets. The red one is A, blue one is B, and to take the intersection of these two sets, we need to take the elements with the minimum membership degree of this set. So the red shaded line or red shaded area shows the intersection of these two fuzzy sets. And we have a complement of fuzzy sets. The red lines shows the fuzzy set A, and if we take the complement, we want to deal with the complement of fuzzy set A, we need to subtract numbers, all of the membership degrees. from 1. So this is a continuous one. So we just take the something like projection here. And we have excluded middle axioms for crisp case. Of course, I don't mention all of the set properties, not to bore you so much. So we have crisp set A and its complement, as we know, and we have excluded middle axiom here. The union of a set and its complement is equal to universal set, as we know. And we have another axiom, axiom of contradiction. The intersection of a set and its complement is an empty set, as we know. But in fuzzy case, the excluded middle and contradiction axioms don't hold. So the main difference may be from the classical set operations of fuzzy sets is these properties, because we take the maximum membership degree elements when we apply the union operation. Because of that, it doesn't equal to the union of fuzzy set A and its complement is not equal to the universal set, and also their intersection is not equal to empty set, we can say. And another example here is a 40-year-old person young. We have an answer yes or no. Is 170 kilometers per hour fast. We have an answer again, yes or no in means of classical logic. But for fuzzy logic, we have an answer yes to a certain degree, and we have an answer no to a certain degree. And again, I want to show this is a classical figure you can find in each presentation. So, in classical logic, we have yes or no, true or false, but in fuzzy logic, we have some soft transitions between them. Just like fuzzy membership functions, we have linguistic variables. They are like some kind of fuzzy numbers. In classical mathematics, we can say a numerical variable takes a numerical value. 8 is equal to 58 is equal to 45 is equal to something. But for a linguistic variable, it has a linguistic value. So we just say with words, age is old, age is young, not old. I like that one. We can say they are fuzzy numbers, and we can apply some operations on these linguistic variables. Generally, a linguistic variable is characterized by a current tuple. We can say X is the name of the variables, T of X is the term set, X is the universe of this course. Of course, we need to define the universe, and we have the syntactic and semantic rules. After these definitions, we can start applying any of the fuzzy logic methods on these linguistic variables. And we have some operations. So when we design a system, for example, a fuzzy inference system, we just define some of the linguistic variables. I don't need to, there are many of them. So I just define a few of them. And by applying some operations on these linguistic variables, I can obtain other ones easily. For example, we have a concentration operation. For example, I defined the age, old, as a linguistic variable, or young. And if I want to find the very young or very old membership function, so I just apply a concentration operation by taking the squares of the membership degrees. Or I have a dilation operation, which we use with more or less young, more or less old. So by taking the square root of the function or the membership degree, we have a soft we often find in the membership degree, or sometimes we can apply any of these operations more than one. So, for example, if I say very, very old people, so I need to apply the concentration operation 2 times. So I need to take the 4th power of my membership function or membership degree in some cases. And we have another important operation on linguistic variables, which we call contrast intensification. For example, it is indeed an old people. When I say that, for the membership degrees between 0 and 0.5, we take the square and multiply by 2 the membership function or membership degree. But for the membership degrees between 0.5 and 1, we apply the operation. We subtract 1 minus membership degree square. We apply this operation. So if we apply the contrast intensification operation many times, at the end we will have a crisp set. These are the examples of different linguistic variable operations. Here we can say it's little, slightly, very, extremely, and the lines are the original set, and the bold ones are after the mathematical expression is applied for these examples. And for the linguistic variables, of course, we can define with different shapes. It doesn't need to be always triangular. We can define many linguistic variables, and also, as I said, by just, for example, in this composite linguistic variables, which is a combination of some semantic, by applying some semantic operations in the same problem, we can have other linguistic variables, which we call composite linguistic variables. And as I said, we have commonly used one is triangular linguistic or fuzzy number linguistic variable, or a fuzzy number we can say. But repository is also widely used. We have a sigmoid type, or in some cases it changes to exponential or Gaussian shape. And we have another one, shouldered trapezoid. It is also a common shape to define the boundaries of the universe, we can say. And as I said, the word is fuzzy. We have fuzzy information, but we need to have some crisp actions. So fuzzy logic provides us the tools to transform word information from crisp to fuzzy information, which we call is process, the fuzzification process. And then we infer the fuzzy information to come to a fuzzy action. This is the inference process that we learn by using the database. And we make some, we have some rule base in our minds. For example, this is the inference process. And since we need to have a crisp action, we must transform this fuzzy action to a crisp action. This process is called defuzzification, usually. So we have a crisp input, for example. Sometimes it can be also fuzzy input, so no need to fuzzification process. But if we have a crisp input, we need to fuzzify it. Then we need to inform by using the database and by getting help of knowledge base, which we call rules or rule base. And at the end, we need to deposify our results to make an action. It will be a crisp output, of course, for that. And this is the figure of the classical fuzzy inference system. We have the inputs, crisp or fuzzy, we don't know. We have the rule base, for example, for a doctor or a general surgeon, for example, for a patient comes, a thyroid, for example, which is suffering from thyroid disease, and they got some blood tests, T3, T4, TSH, something like that. I don't know. And he has some rules in his mind. He doesn't have millions of combinations, but just the rules. If T3 value is between this interval, or it is not too high, and T4 value is normal, then apply, give this drug. If T4 value is not normal, it's high, and T4 value is low, and TSH value is low, the normal case, so apply this. So he has many rules, but not mathematical rules, not numerical rules, just the rules are fuzzy in his mind. And by applying different rules, he just comes to a solution, and he decides something. And of course, you need to make a crisp action to advise the amount of the drug we can say. And this is just a fuzzy inference system which we use. Or when you go to a restaurant and you have two criteria, for example, for the quality of service and the quality of food, and you have to decide for the tip, and you have three rules in your mind. For example, for the first rule, if service is poor, then tip is cheap. If service is good, then tip is average. If service is excellent or food is delicious, then tip is generous. So you need to give a tip to the server at the end. So you need to make a crisp action. You don't say, I will tip you, I will give a high tip to you, I will give a low tip to you. So you have rules in your mind, and you act as a crisp action. And for the fuzzy inference system, if we have crisp input, we apply all of the rules. For example, this is the first rule, A1 and B1. So at the end of the application, by taking into account the minimum degrees of membership, when you cut where the input is satisfied here. So we have C1, first result, and we apply the second rule for the minimum value. And at the end, we need to make the classification mix by taking into account the results of the two rules. So this is a declassification process. Of course, there are many declassification methods. I just mentioned clear center of area methods here. And also, if we have fuzzy inputs, we can also again apply fuzzy inference system by just taking into account the intersection points of the rule. And in the rule, we have the sets A and B, and the information in the minimum higher degree, we can say we take the again the maximum to find the result. And this is a designed for adaptive neural-fuzzy inference. We call ANFIS. The first one is the first order Sugenon fuzzy inference system, and other one is equivalent ANFIS design by taking into account the neural networks, and some of the inputs are fuzzy and some of them are crisp. If we have only one fuzzy, so the whole system will be counted like a fuzzy system, we can say. And let's go back to our local herbalist example now. So how many grams of herbal tea should a 45-year-old person drink a day, for example? So I don't know how many grams of herbal tea should I drink to be fit or to be healthy. The first question, how can we solve it? So
Gözde Hocam, can I gently remind you that it's been 55 minutes, and so maybe you can plan your time.
Okay, thank you. I have only 5 slides. Thank you. And we need to define the rules first, according to the herbalist. I mean, he has a rules in his mind. If young, then the result is 20 grams. The second rule, if old, then the result is 50 grams. So the first definition of the rules is okay. And we need to define the concepts. He has the definition of young in his mind and old in his mind. So I need to define this concept as a membership function. So I need to find a mathematical formula for that. And of course, this is for the herbalist. They are all subjective. If I shaped or you shaped, for example, the mathematical formulation of the membership degree, maybe the boundaries will be different, and maybe you decide to use other types of membership functions. So for the young people, I have this formula. If the person is between 25 and 60 years old, this is the crisp output, crisp input, I'm sorry, and we apply 60 minus x divided by 35. The other one, old definition, if the person is between 40 and 75, so we will apply x minus 40 divided by 35. And also we have another here, not very old, or not too old, we can say. So first we need to make an operation on this linguistic operations. First I need to find too old, then it's complement, not too old. So now we have the definition of concepts. It's now time to decide about the amount of a 45-year-old. These are the shapes, 45-year-old person. So what is the degree of a 45-year-old person being young? So I want to first decide his or her membership degree to being young. So I apply my formula. So I can say that according to the first rule, the result is 20 grams by 43 degrees, 0.43 degrees. And I need to, for the 45-year-old person, because look at the young is between 25 and 60, and the old is between 40 and 75. So 45-year-old person satisfies all of these, and both of these membership functions. So I need to apply the second rule also. So according to the second rule, the result is 50 grams by 14%, we can say. But what is the result? So what we can say? We need to take an aggregated value, and this is called the classification process, by taking the weighted average of all the rules. So the results for a 45-year-old person, he or she should drink 27.37 grams per day. Of course, this is an extreme example, but I just want to show how we apply fuzzy inference system. This is the Sugena type. We have many types of fuzzy inference system, but most widely used ones are Mamdani type and Sugena type. This is the Sugena type fuzzy inference system design. We have a function at the result of that. But if we don't have the crisp input, for example, I just say young and not too old, I can find it's according to the figure. So I apply young and not too old in the intersection point. These are the brackets of this young and not too old membership functions. So the intersection for the maximum intersection membership degree is 1 here. So the firing degree of the rule is 1, we can say. And for the other one, old and not too old, again, we have 2 membership function. We take the intersection and look at the maximum membership degree in the intersection point. So the firing degree is 0.62 here. And we apply the rules again. This is the Sugena type, Mamdani type, exactly, we can say. According to this, for a person who is not too old, he should drink 31 or 48 grams per day for this herbal tea. And this is the end of my slides. So 8 centuries ago, our respected Nasrettin Hoca, I think, used fuzzy logic. I didn't put the English translation here because it makes sense in Turkish to me a lot. So in fact, my main study areas are just the applications of fuzzy logic. If we have time, I will also present some classroom methods because they find many application areas in fuzzy logic science, important application areas in data mining and also in clustering methods. So we divide the clustering methods into five parts in general, as partition methods, hierarchical methods, density-based or neighborhood-based methods, grid-based, and model-based methods. I generally deal with density-based, neighborhood-based fuzzy cluster methods, but one of my methods are in the intersection between hierarchical and density-based methods. So I would be glad to have another presentation on that area also. And thank you for your patience. I talked too much.
Oh, thank you, Hocam. No, you're almost on time. We started a little bit late, and thank you for the presentation. At this time, I'd like to ask the viewers if they have any questions. Most of them have privileges of presenting or turning on their mic, I guess, so shouldn't be a problem.
Mahmut Ali Hocam, if you allow us, let's switch to Turkish for the questions and answers.
Hocam ben Gözde Hoca'ya bırakmıştım kendi tercihiyle İngilizceyi. Tabii buyurun. Tabii.
Buyurun hocam, fark etmez.
Hocam ben teşekkürler sunum için. Aynı zamanda ders de veriyorsunuz fuzzy logic ile ilgili.
Evet hocam.
Dönem. Ayrıca biz bu senenin sonunda bir de bu infus, bu fuzzy logic'in içerisinde yer aldığı bir de konferans düzenliyoruz. Uluslararası bir konferansı burada. O yüzden bütün bunlar çok iyi denk geldi. Umarım hani bizim gerek öğrencilerimizle gerek öğretim üyelerimiz arasında fuzzy logic'le ilgilenen çok kişi yok. Ama bir şekilde ucundan tutmaya çalışıyoruz. Bu sunumda o açıdan da faydalı oldu. Yani bu fuzzy logic, yani önümüzdeki günlerde bu bizim endüstri mühendisliği alanındaki problemler hakkında şöyle bir değerlendirme yaparsanız, acaba bizdeki problemlerde hani nasıl uygulayabiliriz, ne yapabiliriz gibi, o konuda hani görüştüğümüzde de yönlendirici olursanız seviniriz hocam.
Ben ders alan öğrencilere zaten söyledim, hani daha test konuları belirlenmemiş ama en azından hocalarınıza da söylersiniz, seminerden sonra belki okullarında uygulanabilecek, kendi konunuzun fuzzification hali nasıl yapabiliriz diye bir fikir oluşabilir dedim. Bu tabii benim tam yani fuzzy logic kullanıyorum sadece ben. Dediğim gibi kümeleme çalışıyorum. Belki onlarla ilgili bir şey yapabiliriz öğrencilerimize,
evet.
veya multi-criteria decision making yöntemleri hakkında bir şeyler yapabiliriz. Konuşacağız yani onları. İnşallah bir şeyler çıkarır hocam.
Teşekkürler hocam.
Evet, ben fuzzy logic dersini aldığımda, ben de lisansüstü doktora yaparken almıştım. Güzel projede yapmıştık o zamanlardan beri. Son zamanlarda bu infus'la beraber tekrar bizim gündemimize de girdi ama ben çok uzun süre uzak kaldım. Ne yöne doğru gittiğini de merak ediyorum. Son yani işte 10 yılda neler oldu, neler bitti bu konuda diye. Yoksa fuzzy logic, fuzzy mathematik, işte inference şeylerini yapmıştık doğrusu. Belki ayrı bir küçük görüşmede biraz daha hani bakıp doğrusu merakla neler yapılıyor diye öğrenmek isterim.
Bu çok kuş bakışı oldu hocam. Yani aslında 65'te önerilmiş fazı, yani aslında anlattım size type 1 fazı set, artık type 2 çıktı. Yani sadece değişkenin fazı olmadığı bir üyelik derecesi veriyor. Üyelik derecesinin de fazı olarak verildiği type 2 fazı seti, intrinsic fazı set var. Artık uygulanan bütün şeyler, yöntemler, yani fazileştirilmiş bütün yöntemler ikinci tür bulanık kümelere ve intrinsic fazi kümelere yani uygulanabiliyorlar. Öyle bir şey var, dönüşüm var.
Sevgili Önder Hocam, buyurun.
Teşekkürler hocam. Gözde hocam sağ olun, çok aydınlatıcı oldu. Teşekkür ederim. Benim küçük bir sorum var. Birazcık teknik ama çok da değil. Verdiğiniz örnek gayet iyi oldu, bu yaşlı genç örneği. Onu biraz egzajere ederek devam etmek istiyorum. Yani orada şöyle gelen bir kişiye yaş durumuna göre işte yani fazi dünyasında konuşuyorum. Ne kadar besin vereceğimizi ya da ilaç vereceğimizi işte bir tane bir yöntemle belirleyebiliyoruz. Bir çeşit weighted average gibi bir
Evet.
şey değil mi? İnterpolasyon gibi bir şey yapıyoruz. Yani çok uzağım konuya, kusura bakmayın şeyleri.
Ben bir tanesini verdim hocam. En kolay
Evet.
weighted devirici var.
Evet.
Çok fazla yöntem
Evet.
var. Evet.
Bir yöntemle yapabiliyoruz. Bunu anladım gayet. Sağ olun. Bir şunu sormak istiyorum. Bu o gelen yaşının fazı olduğu bir kişiye verdiğimiz bir bir karar. Ama başka karar problemleri de olabilir. Sistemi ilgilendiren. Mesela ben böyle bir sürü insan olabilir. Stoğumda ne kadar besin bulunduracağımla ilgili bir karar vermek istiyorum. Dolayısıyla bunlardan hangilerinin yaşlı kategorisine gireceği, tam her birinin yaşlıya girme kategorisinde bir weight'leri var. Ama önüme gelecek besin talep eden müşteriler tırnak içinde hangi sıklıkla yaşlı grubundan geleceği ya da genç grubundan geleceğinin onları da mı fazı planlıyoruz? Böyle bir planlama için ne yapmam lazım? Ya ben elimde besin biriktireceğim. Bir kişiye vermeyeceğim bunu. Bir sürü kişi gelebilir ileride.
Farklı yaş gruplarından.
Evet, farklı yaş
olabilir
gruplarından
diyor.
yani oradaki biraz soru şeyle de ilgili. Yani bu probability fazı ilişkisiyle de ilgili. Ben bununla gelecekte gelenlerin yüzde kaçı yaşlı olacak, yüzde kaçı genç olacak ki yani o ratio'su ne olacak ki ona göre bir planlama yapayım. Bu durumu nasıl halledebilirim?
Onu da yine hani şeyleri bulurken de o yani sonuçlarını da yüzde şu kadardır diye değil, hani crisp olarak değil, onu da fazi olarak verilebilir. Öyle bir şey olabilir ya da gelenlerine göre, hani aldıklarınıza göre, kişilerin yaşlarına göre daha doğrusu bir normal şey gibi, yani fuzzy regression'la da yapabilirsiniz hocam, tahmin etmek istediğiniz şeyi.
Evet, yani yüksek sıklıkla gelecek, düşük, yani yüksek frekansı olacak, düşük frekansı olacak.
Evet.
Onu da bir fazi bir şey gibi tanımlayıp onu da sonra bir operasyondan geçirebilirim diyor.
Evet, hani herhangi bir sistemde bir tane değişkenimizi bile fazi olarak kullansanız sistem artık fazi hale gelmiş oluyor. Ya da bir işte optimizasyon probleminde amaç fonksiyonunuz fazi olabilir veya sadece kısıtlarınızdan bir tanesi fazi olabilir. Yani amaç fonksiyonunuz, kısıtlarınız tamamı da fazi olabilir veya sadece kısıtlardan bir tanesi fazi olabilir. Artık optimizasyon problemimiz fazi hale gelmiştir diyebiliriz.
Tamam, sağ olun hocam. Teşekkür ederim.
Başka sorusu olan var mıydı acaba? Eğer yoksa hocam çok teşekkür ederiz. Yakın zamanda zaten gelip gidiyorsunuz. Dersiniz var. İnşallah en kısa zamanda tekrar konuşmak üzere. Herkese de katılımcılara da teşekkür ediyoruz.
Ben teşekkür ediyorum. Nazik davetiniz için tekrar teşekkür ediyorum.
Sağ olun. Sağ olun.
Dear Gözde Hoca, thank you very much also for doing your lecture in English. I appreciate it. Thank you very much.
You're
It was
welcome.
very, very informative and interesting. Thank you.
I'm glad to hear that.
Okay.
Teşekkürler hocam, Gözde hocam.